Hello students. So in some natural phenomena this chapter, now we will study application of inductive charges. Now it is very clear to us how the charges will be transferred through the conduction and induction. Now we will study the applications. Okay. So here, the application of inductive charges can be divided into high power and low power categories. So, this can be divided into high power and low power application and high power application. High power application. The low power applications generally include handheld devices, phones, computers, other devices which are charged at power level below 100 watts. And you can see that the charger of the mobile phone, you have a very small voltage or very low voltage here. That is approximately 5 volt, right? This thing, so the low power applications, these are while you are charging the phones, whenever the handheld devices you are using. So with the help of the wireless charger are also available. These wireless chargers, these are the applications of the low power of the inductive charging. Okay, of the inductive charging. And other devices also can be done, that is the computers and other devices also done. Now high power inductive charging application include the charging of the batteries that has the power level above the 1 kilowatt. So high power, this is above 1 kilowatt, it is above 1 kilowatt, and low power, this is below the 100 watt, below the 100 watt. And mostly we are using electric vehicles, charging of the electric vehicles where automated and wireless inductive charging is provided as an alternative to plug-in charging. Okay, so we have two types of inductive charging here: high power and low power. High power, that means greater than, that is higher than the 1 kilowatt, and low power, that is below the 100 watt. Okay. Now the list of various differences between the electrostatic charge and electromagnetic induction. Electromagnetic induction, here the generation of EMF, electromagnetic field. Okay, electromagnetic field, EMF, electromagnetic field. So here you can see that the generation of EMF in a conductor due to the rate of change of current in a nearby conductor without any electrical connection. So there are no electrical connection here, but still you can see that there is a with the help of the induction, you have one magnetic field will be induced. And electrostatic induction, the accumulation or redistribution of electric charges in a body due to the nearby charge body without any physical contact. Suppose you have one charged body or neutral body here, and suppose you have some positive charges here, you can see that some negative charges will be here. So the accumulation or redistribution of electric charges in a body due to nearby charged body without any physical contact, that is the electrostatic induction. And in case of electromagnetic induction, the electromagnetic field will be created in a conductor. Electromagnetic field will be created in a conductor due to the rate of change of current in a nearby conductor without any electrical connection. Okay, so suppose you have one conductor here, and you can see that there will be some electromagnetic induction here, and it works in long distance. Electrostatic induction, it works for short distances. And electromagnetic induction, it is due to the rate of change of flow of charges. And here the electrostatic induction, it is due to the static charges. The electromagnetic induction, the effect is maximum in conductor, and electrostatic induction, the effect is maximum in insulators. And electromagnetic induction, electric fields of the charges are the reason, and magnetic field due to the moving charges are the reason here. Okay. Now, next, let us do some question answer. Let me change the ink color. Which instrument is used to detect the nature of the charge? We have studied gold leaf electroscope. So, an electroscope is used to detect the nature of the charge. How is charging by induction method used in real life? The charging by induction method is used in charging microphones, smartphones, etc. As induction method is the transfer of charge from one object to another. So, by placing the phone on the dock charge, transfer from dock to phone. Okay. Explain charging by induction. Induction charging is a charging induction charging is a charging method that charges an object without actually, just a minute, touching the object to any other charged object. The charging by induction process is where the charged particle is held near an uncharged conductive material that is grounded on a neutrally charged material. The charge flows between two objects are sorry, two objects and the uncharged conductive material develop a charge with opposite polarity. Okay? Explain charging by friction. The charging by friction process involves rubbing of one particle on another, resulting in electrons moving from one surface to another. This method is useful for charging insulators. Explain the charging by conduction. The charging by conduction is process that involves touching of a charged particle to a conductive material. This way, the charges are transferred from the charged material to the conductor. This method is useful for charging conductors. Okay. Now, what is electromagnetic induction? The generation of EMF, that is electromagnetic field. Electromagnetic field. Electromagnetic field in a conductor due to the rate of due to the rate of change of due to the rate of change of current in a nearby conductor without any electrical connection. Okay. What is the charge transfer complex? What is the charge transfer complex? A charge transfer complex, also called the electron donor acceptor complex, can be defined as an association of two or more molecules or of different parts of a large molecule in which a fraction of electric charge is transferred between the molecular entities. Charge transfer often occurs in inorganic chemistry involving metals, involving metals. Okay, so next move on. So types of electroscope. One is the pitch ball electroscope. One is the pitch ball electroscope. So there are two types of electroscope. One is pitch ball electroscope. Another already we have discussed, that is the gold leaf electroscope. So pitch ball electroscope, that was invented by John Canton in the year 1754. John Canton in the year 1754, and it consists of one or two small light balls like this. Small light balls that are a lightweight non-conductive substance called pitch. So you have if here that is called the pitch. Okay. Now to find if the object is charged or not, it is brought near an uncharged pitch ball. And if the ball gets attracted to the object, it means that object is charged. So this is the main phenomena. This is the main phenomenon of working. Now the pitch ball electroscope, here you can see that one small ball is here made up of pitch or cork or styrofoam hanging from a thread. Here this is the thread, this is the thread, and this one is the pitch ball. And if the object is neutral, the pitch ball does not move. If the object is charged, at that time you can see that if the object is positively or negatively charged, the pitch ball swings. The pitch ball swings like this. The pitch ball swings like this. So if it will swings like this, at that time that indicates that yes, there is a charge in this. There is a charge in this object. So this is the object which we are trying to test. This is the object that we are trying to test. Is there any charge or not inside this object? Okay. Now another thing, that is the gold leaf of electroscope. Already we have told the gold leaf electroscope here. Now gold leaf electroscope, that has been invented by Abraham Bennett. That has been invented by Abraham Bennett in the year 1787, and which is most sensitive than the pitch ball electroscope. And it consists of vertical metal rod. This is the vertical metal rod, this one. This is the vertical metal rod, and with two parallel strips. These two are parallel strips of gold leaf, and two parallel strips of a thin flexible gold leaf hanging from it. And to prevent the gold leaf from drafts of air, it is kept in a glass bottle, or it kept in a glass bottle here, and the gold leaves would spread into an inverted V when charged object is brought near it. So you can see that the gold leaf, that is inverted V like this one. So this, there is a separation in between these two leaves. So in between these two leaves, okay, suppose leaf 1 and leaf 2, in between these two there is a separation. So if you can see that there is no charge here, no charge object here, so the leaf is not separated. Now there is no deflection in the leaf. But if there is a negative charge you are keeping here, at that time you can see that the rod, the metal plate, this metal plate will be negatively charged. This metal plate will be negatively charged as well as the gold leaf. So there will be a separation here. That means there is a deflection here, right? Similarly, whenever you are keeping one, this is the conduction, the charging during the conduction, and this is by induction. So if I am keeping the negatively charged particle and we are not touching the metal plate at the metal disc here, at that time, so this is the metal disc, this is the metal disc, okay, metal disc. At that time you can see that the opposite charge will accumulate here. So if it is the rod is negative, then the positive charges will be here in the metal disc. So if positive charges will be in the metal disc, at that time you can see that there will be some deflection here. There will be some deflection here. Now, if the disc is are connected with a conductor and the conductor is here, there is earthing here. At that time, you can see that there will be neutralization of the charges, because the negative charge and positive charge, they will at that time, this positive charge, they will flow away from this part, and at that time you can see that there will be no deflection here. But if there is no earthing, at that time you can see some deflection here. Okay, so this is the gold leaf electroscope. So we have two types of electroscope. One is gold leaf electroscope, another is the pitch ball electroscope. Another is the pitch ball electroscope. Now, uses of electroscope. So it is used to detect the static charge. The nature of the electric charges can be determined by the electroscope, obviously by gold leaf, and magnitude of two different charges can be compared also. If the deflection, this is a V-shaped gold leaf, if the deflection is less amount, that means less charge is there. If the deflection is very high amount, that means there will be high amount of charges are there. So the magnitudes of the two different charges that can be also compared using this electroscope. So first one, that is, it is used to detect the static charges. Second one, the nature of the electric charges can be determined using an electroscope. Third one, the magnitudes of two different charges can be compared using an electroscope. Next, let's answer the questions. What is an electroscope? Here, an electroscope is a device used to detect the presence of an electric charge on a body. What is an electrometer? An electrometer is an instrument used to measure the charge quantitatively. Okay. Next, what are the types of electroscope? Types of electroscope are pitch ball electroscope and gold leaf electroscope. Straight, true or false? Electroscope is used to detect the static charges. True. Who developed the gold leaf electroscope? In the year 1787, the gold leaf electroscope was developed by Abraham Bennett. What is static charge? How does it differ from electric current? The electric charge is generated by rubbing are called static charges. The static charges do not move while charges move in electric current. What do you mean by electric discharge? How it occurs? When the negative and positive charges meet, streaks of bright light and sound are produced. This process is called electric charges. Electric discharge. For example, electric discharge occurring between two or more clouds or between clouds and earth. What is earthing? What is the application of earthing? The process of transfer of charges from a charged object to the earth is called earthing. It is provided in building to protect from electrical shocks due to any leakage of electrical circuit current. Okay. How does electric discharge occur in clouds? At the time of thunder, negative charges are accumulated near the clouds and positive charges near the ground. When these charges meet, electric discharge takes place between the ground and clouds. In this process, a large amount of energy is released. Okay, so up to this much for today. Thank you all. Thank you and have a nice day.